R-CADT, Research Center for Advanced Decision Technologies is pleased to invite you to participate in the postgraduate level course. Oil and Gas Industries Enterprise-Wide Optimization. A different course in advanced optimization. Summary. The course covers the math modeling of the following process in owned supply chain. Oil and gas artificial brains, oil exploration and exploitation, multimodal transportation of petroleum and petroleum products transportation in pipelines, oil blending, transport, and trading, oil and biomass refining, distribution of refined products, blending of derivative products, natural gas supply chain, ETRM, energy trading and risk management, owned energy efficiency, owned state estimation, Kalman filtering, and owned supply chains design under uncertainty and risk management. HI operates as a knowledge factory in artificial intelligence and advanced mathematical modeling, focusing on artificial business management, autonomous AI that guarantees objective decisions. Artificial brains integrates organizational decisions based on neuroscience. Enterprise-wide optimization systems, EWOS, customized AI that integrates multi-problem model systems and high-complexity mathematical models, traditional models that are part of our artificial brains. The course covers the following artificial intelligence methodologies. Predictive artificial intelligence, machine learning, framework, advanced probabilistic models, neural networks, support vector machine, and hybrid methods, Kalman filter, decision-making artificial intelligence, framework, economics and optimization, large-scale optimization methodologies, mathematical programming with equilibrium constraints, parallel optimization, real-time autonomous distributed optimization, and artificial brains. RCADT and/or HI issues a certificate signed by the scientific coordinator, for which the student must participate in at least 20 conversation sessions. The course covers the following artificial intelligence methodologies. Predictive artificial intelligence, machine learning, framework, advanced probabilistic models, neural networks, support vector machine, and hybrid methods, Kalman filter, decision-making artificial intelligence, framework, economics and optimization, large-scale optimization methodologies, mathematical programming with equilibrium constraints, parallel optimization, real-time autonomous distributed optimization, and artificial brains. The instructor of the course is Engineer Jesus Maria Velasquez Bermudez, Ph.D., who, in 2024, won the Artificial Intelligence Award of the Industrial Engineering and Operations Management Society, IEOM. Hypothalamus Artificial Intelligence brings real-world oil and gas business optimization practice to academia to teach enterprise-wide optimization systems implementation. Parallel thinking. Like paper-based math, sequential math for single-processor computers is dead. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics are autonomous, parallel, and distributed. Objective and structure. The material covered in the course covers two broad areas of applied mathematical programming: oil and gas systems and markets modeling, and implementation of owned enterprise-wide optimization systems. Both topics are addressed from HI's vision of multi-problem mathematical models, in which the development of computer solutions is oriented from the programming of algebraic formulas to the structuring of models, integrating the problems that make it up, as a Lego game. The student will learn about the main technologies for the implementation of mathematical programming algorithms and will learn to see them from this point of view, typical of Industry 4.0. But it is not a specialized course in algorithm implementation. Structure. The course is based on specialized academic activities aimed at training the participant in the main mathematical problems that must be solved in the strategic and tactical planning, operations scheduling, and process control of oil and gas systems and markets. The basic unit of the course is the virtual session with an average duration of 90 minutes each. To do this, the classes are recorded on videos by artificial intelligence. The classes are grouped into modules that cover the petroleum product supply chain. After watching the videos, students must attend face-to-face virtual sessions, in which the course teacher will clarify existing doubts. 2 conversations are held monthly. Students should submit their questions in advance. Objective: the course program is aimed at training professionals, at the graduate level, in applied mathematical modeling, taking advantage of the instructor's 50 years of experience in the area. The course is aimed at professionals who want to become applied professionals in highly complex mathematical modeling, with emphasis on the use of methodologies and technologies for the solution of large-scale optimization problems. It is also useful for graduate students who are pursuing theses or research projects related to optimization applied to complex problems. It encompasses the teaching of the theoretical foundations of large-scale optimization, with an emphasis on atomizing problems to solve them in parallel computers or computer networks. The objective is to present the integrated vision of real-time distributed optimization, RTDO, as the mathematical way to model the cyber-physical systems of Industry 4.0. It is characterized by the integration of multiple algorithms that continuously cooperate to solve the problems of a multi-agent system, independently using the parallel computers of the agents and sharing information to cooperatively achieve an optimal solution. This theory is constructed using the fundamental theories of partitioning and problem decomposition, Benders, Lagrange, Dantzig-Wolff, cross-decomposition, and others. By the end of the course, the participant should be aware that future mathematical models will solve problems of more than 1 billion variables, or perhaps trillions. The course covers the following topics: next-generation analytics and advanced computing, parallel thinking for the partitioning and decomposition of complex systems, oil and gas industries, enterprise-wide optimization, specifically Bender's partition theory, Lagrangian relaxation, Dantzig-Wolff decomposition, cross-decomposition, subrogate programming, and asynchronous parallel optimization sliding optimization. Advanced concepts of artificial brains, and implementation of oil and gas industries, enterprise-wide optimization in the real world. For the different methodologies, examples of real-world problems and computer programs are presented, so that the student understands the application of what is taught. The course is aimed entirely at the oil and gas sector, therefore, all the material will deal with this industry and other energy-related businesses. Obviously, those who get the most out of the course are mathematical modelers experts in the oil and gas industry. But executives, managers and engineers in the industry are trained to understand the present and future of artificial intelligence for decision-making, to structure and participate in projects of this science of the future. Artificial intelligence is accessible to everyone, but understanding its true scope requires proper training. High can teach knowledge, but it cannot create understanding. This is the responsibility of the student. The paper Operations Research Enables Better Planning of Natural Gas presents the use of mathematical optimization models for pipeline planning. China's natural gas consumption has nearly doubled in the past 5 years. To better meet demand, the China National Petroleum Corporation, CNPC, China's largest producer and supplier of oil and natural gas, partnered with researchers from the University of California in Berkeley, and Tsinghua University in Beijing to apply operations research to develop and implement new software to help CNPC to improve the management of its pipeline network. Previously, all pipeline production and construction planning for CNPC, which controls 72% of the country's natural gas resources and 70% of its pipeline network, was done by traditional methods using spreadsheets. However, due to the increasing size and complexity of the network, the use of the traditional method resulted in excessive costs and wasted resources. Since implementing the new software, which uses a 3-stage convex relaxation method and iterative piecewise linear approximation methods, in late 2014, CNPC has obtained approximately $530 million of American dollars in increased earnings, 2015 to 2017. In addition, the resulting increase in the efficiency of the existing pipeline network allowed the company to postpone the addition of new pipes, leading to an official budget reduction of more than $20 billion of American dollars in construction costs for the following 5 years. The image present the algebraic formulation of the natural gas pipeline transmission model. Without fear of being wrong, It can be said that mathematical optimization models are the goose that lays the golden eggs of China National Petroleum Corporation. Oil and gas industries. Enterprise-wide optimization and advanced analytics solutions. The interested party can watch the webinar, in Spanish, live. Supply oil chain optimization. Advanced analytics solutions. To have an overview of mathematical modeling in the oil sector. The oil industry includes global processes of exploration, extraction, refining, transportation and marketing of petroleum products. The largest volume products in the industry are fuels, natural gas, fuel oil, and gasoline. However, petroleum is the raw material for many chemicals, including pharmaceuticals, solvents, fertilizers, pesticides and plastics. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. At the origin of mathematical models in computers, starting in 1947, decision support systems, which represent the optimization system of an owned company, have been visualized as composed of multiple mathematical problems, one for each line of the table, which are operated individually and communicated sequentially by humans. This way of operating produces solutions close to the optimal, but not optimal, because they generally have no feedback. The current technological revolution completely changes this approach. Today, OM's business optimization can be visualized as a single supermodel, composed of submodels, which in turn are made up of mathematical problems, one for each line of the table, which are solved by running in parallel, autonomously, communicating with each other, and managed by a mathematical artificial intelligence, produced by a generative artificial intelligence. Theme plan. Duration. The total duration of the course is 50 hours of training, divided into approximately 25 sessions of 90 minutes each session. The course is designed for the student to take 1 or 2 classes each week. However, the speed at which the course is carried out depends on the student. There is no class calendar. Start date of the virtual course. At any time. Classes are recorded using artificial intelligence. All videos are offered in English, and some of them in Spanish. Being on YouTube, all videos can be read in another language using the subtitle service, CC. Every 2 weeks, a discussion on a specific topic is held, which all students are welcome to attend. The table summarizes the plan of topics to be discussed. Continuation of the previous table. Project. If the student wishes to carry out an advanced analytics project during the course, they can indicate this to the scientific director. If accepted, an advisory program on the project would be jointly defined between the R-CADT and the student. General conditions. The price of the course is $1,000. Student discounts are offered as follows: 50% to undergraduate students, and 20% to master's students. The course may be taught under the in-company modality. In this case, prices vary depending on the number of students. Companies, public bodies, universities and research centers are considered. In the case of professional and trade associations, research centers and universities, HI proposes bilateral agreements analyzing each specific case. For more information you can write to the email that appears on the screen.